Cool. All right, so I'm just gonna get started here. I'm gonna assume everyone has Fusion up at home. If you want me to stop or go back or slow down or whatever, just let me know. Unmute or questions, obviously. Yeah, for those who weren't here at the beginning, I'm expecting this to be like half hour to an hour, depending on how quick we end up moving. This is gonna be like very, very basics of Fusion. So start like right at the beginning. And yeah, so if anyone has any questions now, otherwise I'm just gonna get going. Is everyone all set? All right, sounds a yes. All right, so Fusion 360. So I guess we'll just start with like quick program overview, what we're looking at here. Starting from the top left, this up here is your account. If you are working as part of a team, you'll see all your other team members down here. Right now, we're not. This whole left pane here is your data panel. This is like your file browser for all of your projects and stuff. So if you like click from home, this is all the different projects you have, and all your files and stuff will be stored here. Fusion is cloud backed up, so like if I were to log on anywhere else, I would see all these same projects and all these same files. So we're going to work in here. Up here, we've got, this is like your file. So this is exactly like every other program, save and all that fun stuff. Undo, redo, Control Z and Control Y do work, or Apple Z, Apple Y. Up here, any designs you have open will show up just like tabs in Chrome or whatever. This dropdown is what's called like your environment. So these are all the different functions that Fusion has. 99% of our time is going to be spent in design. This is the actual like 3D modeling space. And then the other 1% is going to be in manufacture. This is where you take 3D models and convert them into CAM for like the router or a CNC. There's a bunch of other tools in here that are really cool. Rendering for like nice fancy images. This is what you see on Chief Delphi. Animation, we don't really get into much. Simulation we'd like to get into. This is like stress analysis and stuff like that. This is sneaky, not that hard to use, but is definitely beyond the scope for today. And then drawings, we will not get into today, but we will get into in later workshops. Working across up the top here, solid, surface, sheet metal, and tools. These are the 4 different, basically like chunks of tools that you have to work with. We don't really work in sheet metal, don't really need to worry about surface. Again, 95% of our time will be spent in solid here. We do use some of these tools, but we'll get to that at a later time. This here is called your design browser. It can be minimized with this, maximized. This is pretty empty right now, but everything that you make in this design is going to show up in this design browser. And I mean like every object, every plane, every drawing, every joint. This is like your roadmap to everything you're dealing with here. To go along with that, down at the bottom, this here is a design timeline. It is obviously empty right now as we have not yet done anything, but every motion and action that you do will show up in here in order, and you can click and drag this piece back and forward to go back and forward in time in your design. And we will get to that today as to how that's useful. Up here, top right, this is a camera tool. There's nothing to look at here, so I'm just gonna jump over to this. This is the part we're gonna be drawing today. So this camera tool, if you're ever lost or stuck, you can click on a face and it'll change to that view. This thing is super nice. So, and then camera controls with the mouse. By default with Fusion, click and hold your scroll button is like drag around. Shift and then click and hold scroll button is like sort of zooming and panning around, and then zoom in and out is just scroll wheel. For those of you coming from SolidWorks, so I know Josh, this was a life changer for you. If you come up to your name up here and click preferences, this little drop down right here, pan, zoom, orbit, if you're coming from SolidWorks, you can just change those shortcuts to be from SolidWorks and you won't have to like relearn or get confused. So this will just change which buttons, because I have no idea what it is for SolidWorks. But yeah, so we'll stick to Fusion for that. Some other stuff to see in here, if you go into design, you want to make sure this design history is got capture design history on. This is the default, shouldn't be an issue. And these words, parametric modeling, we're going to talk about a lot today. This is easily my favorite part of Fusion, and I think probably the single most powerful thing it does. And if you design stuff right with parametric modeling, you can make your life much, much, much easier down the line. And then one other thing to check, if you just go into default units and design, this is just your default unit for when you make new parts. I like inches. We as a robotics team use inches. I think the default might be millimeter, so you will want to check that. You can always double check that inches, millimeters thing. If you look in document settings in your design browser, it'll tell you the units. If you need to change it, you can just click this. Here's your drop down, and there's all your options. All right, so like I said, this is the part we're going to be drawing. This is a real part we used on the robot. This is a bearing plate, basically, that gets bolted down to 80-20, which is the stuff that looks like this. It has 2 1/4-inch holes to put 1/4-inch bolts into the slots of the 80-20. And it has a 1 1/8-inch hole up here, which is a press fit for almost all of the bearings that we use. So like the 1/2-inch hex bearings and stuff. This also happens to be a really nice flat. It's basically a 2-dimensional piece that just has a little bit of depth to it. So it's a good, easy thing to draw. But it's also a good example for a lot of the stuff Fusion can do. So let's get started. So I've got here Untitled. This is a brand new design, haven't done anything, which you can see down in the timeline here. First step, as I'm sure all of your teachers have told you with like Word docs and stuff, is to save this. So we're just going to call this like bearing plate or something. Save. You can see that that's going to show up here in your data panel. This little wheel is the cloud syncing thing, so you can continue to work, and this is just going to put it up on the cloud just in case you need to get to it from somewhere else. For today, I don't need anything else for the data panel, so I'm just going to close that, get a little bit more workspace. If I do need to open that up again, it is the little 3x3 square up here. All right, so we are saved. First thing you want to do, and I cannot emphasize this enough, is Fusion has a design hierarchy where you basically have your overall parent design, bearing plate, the thing we just saved, and within your parent design, you have components. This is far and away the #1 way you can screw yourself over in like the first 30 minutes and have a lot of trouble with the design later on. So what you want to do before you do anything, before you draw anything, any sketches, is make a new component. That's this button up here, new component. Click that. Here's our dialog. For this, we're just going to be from an empty component, which basically means there's no parts in this yet. We're going to call this bearing plate. That is going to sound redundant. I know, and it's okay. The parent here, basically, like I said, it's got the hierarchy. So I want this parent to be the design itself. So the parent is that. So this component is going to live 1 tier below the parent design. And this activate thing, we're going to have that checked, and it's not sheet metal. So here it is in the design browser. This little radio button here is the activate button. For now, there's not much to see because nothing actually exists. But again, you want to be working on one component at a time, and you want to have that component activated whenever you're working on it. I'm going to go ahead and expand this. Like I said, this thing has its own origin. As we start building it up, this is going to have its own bodies and sketches and stuff, and we want to keep everything that's related just to this bearing plate under just this bearing plate. This gets so bad if you don't do this right, so I cannot emphasize this enough, that you want to have just be working one component and make sure you're activated with this little radio button here every time. All right, so to start this thing, what I think we want to do is basically make about half of this in 2 dimensions. Most of CAD, at least with Fusion, is done by drawing a 2-dimensional shape and then extruding it, which gives it like depth and makes it 3-dimensional. The way we start that is up in this create, this little icon here, create sketch. This basically brings you into a two-dimensional workspace where you can draw your part. So we're going to click that. It's going to ask you what plane you want to put that sketch on. Functionally, this doesn't really matter, but I like doing things on the XY plane. So that's like, imagine if you're looking down at a tabletop, that's the XY plane. You can just click on that. And so you see a bunch of stuff has changed here. We're now working in a sketch. So we've got our little toolbox over here. And you'll notice this whole top bar is different. So now our create, instead of being those 3D tools, are now all two-dimensional tools. We've got some different modify tools, and we've got a whole bunch of red constraint icons. These constraints are the number one thing I want you guys to take away from today, and is far and away the most important part of parametric modeling. But we're going to talk about these as they come up. So this part is generally a rectangle. So we're going to start with that in our sketch. So if you come up here to create, you can see all these shapes. This is like stuff you learned in geometry. So like rectangles, circles, arcs, ellipses, all that fun stuff. We're going to start with a rectangle. You can just click R at any time for this as a shortcut. So I'm just going to do that. R, you'll notice it's the same thing as this rectangle up here. For shapes that have multiple ways to draw them, like a rectangle, all that stuff will show up in the top right over here. So what we want to do is have a rectangle that starts here at 0, 0, goes up a certain amount to the right and to the up, and then that's it. So we're going to want this 2-point rectangle. If we wanted to draw the rectangle centered around the origin, for example, we could use that. And if we knew the rectangle wanted to be like 3 squares, we could do that. But I find 2-point rectangle does about 95% of what you want to do. So we got 2-point rectangle selected. This cursor here is important. If you notice that it's sort of like a gray cross, this basically means that if you were to click and place this first point, it's not going to be what's called constrained, which means it's sort of floating in space. It's not related to anything else in this design. What we want to do is relate as much as we possibly can to each other in the design, so that if we ever have to come back and change it, which we will, it'll make it much easier to do so. The one point that we do know exists in this design is 0, 0, the origin. So this is the imaginary point 0, 0, 0, like on a graph in space. So this is like our imaginary center point of everything. You'll notice when you mouse over that, your cursor changes from a cross to a blue square. Blue square basically means it's going to be constrained, and it's going to be constrained with something called coincident. We're not going to worry about that right now, but know that it basically means the first point of this rectangle is always going to try to be at 0, 0, which is what we want. So we're going to click for our first point. So now we have the ability to make a rectangle here. If any of you have watched Dan CAD, I'm going to show you what Dan does, and then I'm going to tell you why it's wrong. But we'll start with this. So what Dan does is he'll make his rectangle, and he'll just click somewhere. So now we've got a rectangle of who knows what size, and the second point is who knows where. What Dan does, and you can do this too, but it would be wrong, is he uses this dimension button, sketch dimension. The shortcut for this is D, to say, all right, now that I've made my rectangle, I actually meant for this line to be like 2.75 long. And you can click enter. Now it knows that line's 2.75. And then you can click this line and say, all right, that was supposed to be 2.5, but I missed by like 9.3 thousandths of an inch. So 2.5, enter. So what you end up with here is a constrained square, but it took a whole bunch of clicks and it was kind of a pain. So I'm just going to Control Z a couple times, undo, to get out of that. What I prefer to do is use R for rectangle, or just click. When you click and drag this thing up, you'll notice that the 2.61 there is highlighted, so you can change the text. I like just plugging in these numbers straight away. So we're going to make this 2.5 inches tall and 1.75 inches wide. You might have noticed those little locks that appeared next to the numbers. So those locks appear as soon as you've typed something in and then press tab to get out of that field. The lock is basically the same thing as saying this dimension is going to be constrained. So instead of like clicking D, dragging that thing over, double clicking it, changing the value, clicking enter, you can just type it in here and you get the same end result. So here's our 2.5 by 1.75. I'm going to press enter. There's our rectangle. Notice that all the lines are black. That is good. Black lines means that it is fully constrained. So that, as opposed to like this rectangle, which is floating in space and doesn't have dimensions, all those lines are blue. Blue lines generally not good. In the long run, that means that these are not going to update with any changes you make to the design. So we don't want that. So any questions so far? That was a little fast, but excellent. Good silence. All right. Cool. So we've got our rough shape here. The next step we're going to do is we're going to try to add these two bolt circles right here. These are going to be through holes for 1/4 inch bolts. What that means in real life is that you want a 1/4 inch bolt, which is 0.250, to fit smoothly through this hole. What we can do is use this little ruler, this measure tool. You can click the inside face or this top edge to measure. I like doing edges personally. Make this a little, scroll down. So here's our diameter. So that thing is 0.255 diameter. 5 thousandths of an inch is about right for clearance. So if we were to 3D print this, that hole will come out just a little bit bigger than the bolt that's supposed to go through it. So that'll make our lives a little easier when we actually try to put this onto something. So what we're going to do is put 2.255 inch holes right about here and right about here. Now, obviously, we could do what we just talked about the wrong way. Could put this circle like there, put that circle like there, and then dimension everything, and it would take forever. Or what we can do is try and do this as parametrically as possible. So basically building everything up one shape by one shape. So I know that this hole I want to be about a 1/2 inch up from the bottom because 80/20, which is 1 inch wide, has its slot a 1/2 inch up from either side. And we know that we're going to put that about, let's call it a 1/2 inch in as well from the edge. So what we can do is, if we were to press R for rectangle, here's that 2-point rectangle again. We can constrain this to the bottom, 0, 0. There's that coincident constraint again, that's important. And then drag this up, and just like before, type 0.5, there's the lock, 0.5, there's the lock, enter. So here's our nice black lines, constrained square. If we decided later we wanted to change this, we can just double click these numbers, make that 0.625, and it'll update everything. And now we know we want to put that bolt hole right here up at the end. So we will come up here to circle. This is exactly the same as rectangle, but there's like a bunch more ways to make circles. All these options here, the different geometric ways you can make a circle. So by defining 2 opposite points, by defining 3 points around the circle, 3 things it's tangent to, 2 things it's tangent to, and then the diameter. Or what we use most of the time is the center diameter. So you tell this thing where you want the circle to be and how big the circle is. We want the circle to be right at this point. Here's that, again, that coincident square. So that's good. That means that no matter what we do to this design, the circle is going to try to stay at this corner of this rectangle. And we know that this rectangle is going to try to stay at this corner of this rectangle. So this hole is always going to be these 2 dimensions away from that bottom, which is what we want. So we'll type in our 0.255, enter. There's our circle, nice and black, just the same. So that's good. That's one hole. There are roughly 1 million ways to make the other hole. Obviously, we could just do what we just did, where the rectangle, the coincident, 0.5 by 0.5, enter. We could make another circle, 0.255. That would work. This is okay. But if we ever wanted to change something, like say where this hole was, we'd have to change this. And then if we wanted this hole to match that hole, we'd have to change this one too. What we probably can assume based on this model is that this thing is supposed to be symmetrical up and down, right? The left is supposed to be the same as the right. So we can actually design it like that too. If we said we wanted to take this hole and have this hole exist on the right side, and no matter what we do to this one, if we move it left or up or make it bigger or smaller, we want the one on the right to do the same thing. What we can do is basically mirror this hole onto this side. And the only setup you have to do for a mirror is give it a line or a plane that it's going to mirror itself over. So what we're going to do is come up to our create. Here we've got line. This is exactly the same as rectangles and circles with constraints, but we can actually show off a few more. So if we wanted to start it here at this corner, we've got our nice square coincident line. That means that the first point of this line is always going to try to be at this corner, so the end of this line and the end of this line. That's not where we want this to be for the mirror. We could put it along this line. You'll notice that the cursor is changed to an X. X also means coincident, but it means that the first line of, or the first point of this line that I'm about to draw, I just want to be intersecting this top line, but I don't really care where it is. Which again is similar, closer to what we're trying to do, but not exactly. What we want to do is make a line that's exactly halfway down this piece so that the left and the right can be symmetrical. So what we can do is if we come up onto this line and we slide over to the middle, you'll see that change right here. And you'll notice that my cursor is sort of like clinging to that point. So we still have that X for coincident. So the first point of our line is still going to try to be on this top line. And that triangle basically means midpoint. So when I click this here, this line, that first point is always, always, always going to be in the dead center, intersecting this top line. That is super useful. So we could, if we wanted to put the other point, we could do the same thing here, like in the exact middle of this line, or we could put it coincident to this bottom corner. But what we really want to do to make a mirror is make this thing nice and straight and intersect the bottom at the exact same point. So if we come down to the bottom here, you can see there's 3 different constraints, which again is good. We've got the X for coincident, the triangle for in the middle. We've also got that little perpendicular icon, the little like right triangle thing. So that means that when we click this, this line is always going to try to come to the bottom line, to the exact middle, and at 90 degrees, which is important for mirroring, because if this were at an angle or whatever, that circle might get mirrored like over to here, or who knows. So we're just going to put that right there. Very nice. All right, so we can press escape to get out of that line command. And we're going to mirror that circle onto this side. So click the mirror button. There's not a shortcut for this one by default. This opens up a little dialog. This is the first we've seen of this exact type, where mirror has multiple things it's expecting to know before it can do the thing. The first thing it needs to know is what you want to mirror. So this little icon being blue means that anything you click on in this drawing is what you're telling the mirror command to actually mirror. So I want to mirror that circle. You can see here is 1 selected. If I wanted to mirror like this and that, it would do 4, but I don't. What I want to do is just this circle. And then you have to pick the point or the line that you want to mirror it over. This is the line we just drew. So that, here's the preview where that circle would end up. But just for the sake of showing it off, we could also pick like this line. It would mirror over that. We could pick the bottom line. It would mirror over that, anything. But for our purposes, we want to mirror this one. Based on the way we drew this line, we know that this thing is always going to be dead center and dead straight up and down, which means that when we do this mirror, these two are always going to be at an equal point left and right and an equal point angled, so up and down basically. This preview looks like what we want, so we're just going to go ahead and click OK. So here's our circle. You might notice a whole bunch of these little like pale white icons. If you guys have been paying close attention, you might notice that these correspond to the different constraints I've talked about. So like here's that triangle for midpoint. You can see this defined in the bottom right down here. And when we did that mirror, we got this set of 3. As you click on them, you'll notice all 3 of them get dark. So this one, and this one. So this is a symmetry constraint. This is everything I just explained about a mirror, but in case you were coming back to this after a long time and forgot, or this was somebody else's design, you can always click on these constraints and see what they did. So this basically just means this this circle is going to be symmetrical to this circle with respect to this line. So that's all well and good. And we're going to go ahead and stop our sketch here for now because we're ready to make a 3D shape. So we'll click Finish Sketch. Now, just to prove what happened, that sketch basically exists right at XY0 and is 2-dimensional thick. So it's got no thickness this way and is just like an imaginary drawing. To make this into a 3-dimensional object, notice our toolbar is changed back to 3D design. We can use Extrude. The shortcut for this is E. This is basically what you'd use to make anything like 3-dimensionally exist from any 2-dimensional drawing. Here's that select dialog box again. This is expecting you to tell it what profiles, so what like shapes in a sketch you want to actually make exist. So for us, we want to make this one and this one and this one exist. And that'll end up giving us a plate except those holes, right? And that's what we want. We're going to hold off on that for 1 sec and cancel. And I'm just going to show you guys. So it's kind of a hassle, I guess, to have to pick all these different parts of a drawing over and over, especially as you get more and more complicated. And if you have a lot of like these types of lines or these types of lines that you used to help yourself make that drawing, what you can do is, this is our sketch right here that we just worked on. If we go back and right click and edit this, you can actually define what lines you don't care about for the 3D part as construction lines. So this is just like geometry. You guys might have heard of these. These are lines that you only use to help you make the drawing itself. So you can select any line just with left click. You can right click and do normal construction. This is a toggle. So currently it's a normal line, it's solid. And then if you right click and do construction, it'll become a dotted line. So this line still exists in the sketch. It still has all of its constraints, but when we go to do the extrude and stuff, it's gonna handle all of this surface as one face. We also want to do that with this rectangle down here because this is only exists to help us locate this circle. So we can do the same thing. We can click, we can right click and do normal construction. Notice this is the shortcut for that, X. So we'll just click that and press X. There it is. But that didn't grab this line. Now we know, we'll just do a Control Z. We know that this rectangle was one thing. So if you actually double click any line, it'll grab the whole polygon that that line is a part of. And that'll work like for this one too, right? Here's the whole polygon. So we'll just double click this one and we're gonna make that entire thing a construction line by pressing X. There we go. So now we'll actually do that extrude. So we go over to Finish Sketch, click this, or just press E. And now when we mouse over, 1 click gets us the entire profile that we actually want. So construction lines, you don't strictly need to use them, but it will make your life a little bit easier in the extrude phase. And depending on the complexity of your drawing, it can make a huge time savings. So with extrude, you can like click and drag this thing and see what it's going to do. Again, it doesn't really matter which way you go, but for our purposes, based on this cube up here, we're going to go in the positive Z direction, so up. We're going to click and drag this to like 1. Say that's probably a little too thick, so we can just type in 0.25. And this is exactly the same as dimensioning like with sketches and stuff. As soon as you type this thing in, the program is going to save this number, so if you want to come back and change it, it'll be smart enough to figure out what you mean. The other stuff in the extrude dialog, we're not going to talk about most of this for right now. There's a lot of really cool stuff in here, but for today, the only thing you need to worry about is the default setting, which is profile, one side, distance. Here's the distance, 0 taper angle, and this operation should be new body. We'll just click OK, and there's our piece. So this is cool. Any questions up to this point? Cool. All right. So now it's time to show off what the parameters can do a little bit here. So all of those constraints that we spent all that time talking about and working on during the sketch, If Dan comes to you and says, hey, I want these holes to be a little bit further apart so that the piece is held on a little more firmly, this is the point where all those parameters come in and help you. So if we click on that sketch that we used to make this part, we right click and we say edit sketch. And you look down here on this timeline, you'll notice that the extrude is actually grayed out. So when we clicked edit this sketch, we basically went back in time to before this extrude actually happened. This is cool because now any changes we make, like say moving this to 0.25 instead of 0.5, like Dan wanted, if we click finish sketch, it'll automatically recalculate all of that stuff. So this is where you can change the parts later on after you've drawn them just by doing easy stuff. You can also find all those numbers here in this change parameters window. This is a little bit more complicated, but every number and dimension that you ever use in Fusion gets saved in this window, and you can come back and change any of them at any point. Right, so like here, for example, is that 2.5 inches for the height of the piece. If we were to change this to 4, for example, click OK, we'll see that reflected in our piece. We actually want that thing to be 2.5, so we'll keep it like that for now. But this window is super, super powerful using this. You can get some really cool stuff here. And we will, actually one more thing about that before we go. For any of you software inclined types, these dimension names, D1, D2, D3, these are actually optional variable names. So you can call this like plate height. If you wanted to ever come back and change this and you wanted this to be a little bit more readable for yourself, this is something I do like to do. If I know this part is like a prototype and we might need to tweak it by this or by that, and I want somebody else to be able to come in and figure out what was going on in here. Plate height, plate width. So these are super cool, but for now, we're just gonna leave this as is, and we'll come back and talk about this at a later date. All right, so now we've got our plate. That's starting to look a little bit like this one. Obviously, the next step here would be this bearing hole. So we'll just do a measure to double check. This is a 1.125 inch diameter hole. That's the standard like press fit size for all of our bearings, so hex bearings and stuff. This one, importantly, unlike the bolt holes, which we intentionally made a little bit bigger so that a bolt could fit neatly through it, this is a press fit, so we want to make this thing the exact same size or sometimes even a little bit smaller. So when we 3D print or cut this thing on the router, that hole comes out so that when we push the bearing in, it's a nice like snug fit. So we need to make a 1.125 inch hole somewhere down from the top of this piece. And again, we probably want that thing right in the middle of this. So what we can do is, still with our bearing plate activated, we can actually make another sketch. And like before, we have the option of making it on the 3 planes. So X, Y, Y, Z, Z, X. Or you can also make a sketch on any face of any solid object, right? Like these. So for now, we're gonna make our sketch on the top face of that plate. And this is nice because it inherits all of the geometry that was on there. So you can see here's that rectangle from the outside, and it brings in those circles and even calculates the center of those circles for you. This is nice for us because we know we want that bearing to be a certain distance down from the top and definitely right in the middle. So if we do this just like we did the mirror line, so we do a line, or you can just press L, come up here, check for our constraints. So right there, we know this is going to be coincident and in the middle. And we drag this thing down. So let's say we want that to be maybe 1 inch down. And you'll notice that this gives you the option, as soon as you type in that 1, you can make a 1 inch line at any angle you want. Most of the time, you're going to be working in 90 degrees. If you'll notice, it's a little harder to see, but right here, you actually get that same perpendicular constraint, that same 90-degree thing. This is the same as what we saw when we brought this all the way down to the bottom for the mirror. That's good. That means that this thing is going to be snapped to 90 degrees, so no matter what we do to it later, it's going to stay straight up and down. So we'll just click, that's okay. So here's all our constraints, perpendicular, midpoint. And we know that the circle, so we're going to press C for circle. we want to be right at the end of that line. And we want this thing to be 1.125, big, enter. So we can finish our sketch. Now we can show off the opposite of extrude, but it actually uses the same tool. So if you click that extrude here, and you grab this center face, you could pull this thing up and away and make new parts, but if you actually pull it down and through, Fusion's smart enough to know that you want to cut that hole out. So that's what this red thing is. You'll notice the operation has changed from new body to cut. And this thing is really, really smart. So I found even more advanced, like if you were to drag this into another shape or whatever, it's going to figure out that you mean to join them or whatever. So in this case, we want to cut that out. This looks good. Again, we're not going to worry about the profile, the direction, or the extent. So we'll just click OK. There's that hole. Something looks a little wrong here, though, compared to that one. Looks like this hole is a little bit further up. This is exactly the same as what we did before. We can right-click and edit the sketch we just did. Again, notice we've gone back in time here. We can double-click that and make this more like the right dimension, 0.75. And once again, it'll recalculate the extrude after you've modified that sketch. So this is another way that parametric modeling will come in handy. Is a lot of the times on the robot we'll say like, this was great, but we needed it to be an inch further, or like compression on the ball. And if that was the case, you could just go back and change that variable we made, the plate height, to be an inch higher, and change that line to be an inch higher, and you'd be done, instead of having to redraw the entire thing with this an inch higher. I'm just gonna, for the sake of showing you guys, I'm just gonna Control Z out a little bit. I'm not sure who it was that showed me this. It was one of you, it might have been Sunny. There is another way you can make a hole in Fusion. So I like doing what I just showed you, where you draw the circle fully constrained and then extrude it through. Fusion also has a hole tool. H is the shortcut for this. This is pretty cool. It basically, here's your select box again. First thing to pick is where you want that hole. We know we want that to be the end of this line, this nice constrained line. And then it gives you about 1 million options here for what that hole is supposed to be. So we've got different ways to set the distance. You've got a normal hole, you've got a counterbore or a countersunk hole. So like all those times that we've had people go around with countersinks to make like screws fit flat, you can do that in one step in the CAD here. You've got a simple hole, clearance hole. So like for a 1/4-20, a tapped hole, taper tapped. We don't really deal with this very much. You can tell it if it was a flat bottom drill or a pointed drill. You can tell it how deep to drill the hole, what angle the drill is at, the width of the hole, all kinds of stuff. Sometimes this is handy. You know, if we were doing a countersunk screw or whatever, that would be nice. But for this, we really just need a straight through hole, and I find it a lot easier to just do draw the circle and extrude it through. But here's this tool is. We will talk about this again in further workshops when we get into the more advanced uses for this. But I find if you're just doing a straight hole through a piece, I would just do the extrude instead of going through all this work. So we'll just go back in and redraw all that stuff. Circle 1.125. There's the lock, finish sketch, and extrude that down and through. Very nice. All right, so we are almost done with this piece. It is definitely coming along well. The last thing here is this nice curve on the top. This is not strictly necessary for the function of this part, but it makes it look a little nicer. It uses a little bit less material if we were 3D printing it, and it's a few less corners for you to get poked on. There's a whole bunch of ways you can do this too, but I'll show you two of the, I think the better ways and the more consistent ways. One you can do is make another sketch. You could draw a circle that, let's say, like this one is, this outside circle has the same center as this inside circle, which is why this is consistent, this band all the way around. One way you could do that is if we're in a sketch on this part, you could do another center diameter circle. And here's those constraints again, right? Midpoint, coincident. Circles themselves actually have that coincident constraint, and they also have a center right there. If you see your icon change to a circle, you're constraining something to the center point of a circle or of an arc. So we could click this, and then we could constrain that to the top and middle, for example. That would be cool. Or we could constrain it out to this. And this would be two different ways. So let's do this one, for example. We could finish sketch, and then we could extrude these two pieces down. Now it would kind of do the job, but it's not quite exactly what we were looking for. So we'll Control Z out of that. What I like doing personally is this little tool up here. This is Phillip. It is spelled the same as the fish thing, but it's not the fish thing. Phillip basically lets you grab any edge or edges and turn them into rounds. So what we can do is click on any given edge. So in this case, we want to do this one and this one. And then just like Extrude, you can click and drag and see what this is going to do to your part. And this will obviously do some weird things. If you tell it to do like too big of a fillet, it's gonna do its best to calculate it. But yeah, just use your best judgment. So we'll make that like 0.75. And there we go. That would be a nice little part. Easy to 3D print, holds a bearing, nothing to get cut on. And that's it. So I guess that is pretty much the end of what I had planned for today. A lot of that is some theoretical stuff with, components and design browser stuff and all those parameters. But these are like good design practices and things that if you do these when you're building more complex parts, you'll save yourself a lot of hassle later on. So if anybody has any questions, I guess let's do that now. And otherwise, I am all set.
What was the name of the box that has all the parameters in it?
Oh,
When
so
did you bring that?
that's change parameters. That hides down in this modify menu. This is not in the toolbar by default. I think it should be. If you want to add or change anything in the toolbar, you can just hover over these guys and click the sandwich buttons over here, and it'll give you the option to pin to toolbar, pin to shortcuts. And then once you pin it to the toolbar, it'll appear up here, and you can actually just click and drag these around to reorganize them if you wanted to.
Okay.
I find this to be like one of the better tools in the program. I'm not sure why it's not up here by default, to be honest.
So short of that, if you want to change the parameters of something on the drawing, what was it?
So
How did you get there?
you'd go back to the sketch where you made that decision. So if at this point, say we wanted this bracket to be like 4 inches wide, we could go back to that first sketch, right? Here's where we made all those shapes. Right click and edit sketch. And then notice we're all the way back in time down here. And then we can just double click the parameter that you want to change and say, make that like 4, and then finish sketch. And then because we did nice parametric modeling, everything updates with the model. Nothing is broken. There's no warnings. So here's those 0.75 radius fillets. Here's that hole exactly in the middle, no matter what.
Nice.
Yeah. So it really just depends. I like this one because I don't know. I like having the named variables, I guess. And it's nice being able to like plug this in and just play with these numbers, and see it update live. If you know what you want the part to look like but don't know how to get there, I find this is a good way to like play with these numbers until it looks right.
And then one last question was, what was it you did to make the construction lines, to turn the sketch lines into construction lines?
Yeah, so let's go back into that sketch for a second. Any line, if you just click it to highlight, you can either right click, and then there's the toggle for normal / construction, and the shortcut for that is just X. So if you click and do X, that'll be a construction. Click and X, and that's a normal line. And that works for any amount of lines. So if you double click to get the whole polygon, you could make the entire polygon construction or not construction.
Cool, got it.
Cool. Anyone else?
How do I get the box with the stuff in it?
You speak up a little, Dan?
How do I get the parameter box again?
Oh yeah, so that by default is not up in the toolbar, but if you come into this modified dropdown, it's down at the bottom here. And then if you click the sandwich buttons, you can pin it to your toolbar if you'd like.
All right.
Or you can always just come into the dropdown. There's obviously lots and lots and lots and lots and lots of tools we didn't go over today. We will get to a bunch of these in the future workshops, but for today, I just really wanted to get parameters into your guys' head because that's the big one.
All right. Great.
Yeah, so you can see like even here, these are every single number we did today, all these numbers, and you can change any of these or name them or whatever you want to do. All right, anybody else? Cool. All right.
That was really good, Jason. Thanks.
Thanks.
Yeah. Thanks, Jason.
All right. So I think we're scheduled for next week. I don't know the calendar off the top of my head, but maybe Tejas or Sunny does.
Same day, same time next week.
Same day, same time.
Yep.
Cool.
And, for reference, most of these workshops after in the next few days, they'll be up on YouTube, on our YouTube channel. I think that's where we're posting them.
Cool. All right. So if anyone wants to come back next week, we're going to try and do some more robot stuff. We might do joints, I think, which would be the actual process of putting like this piece on the 8020 and maybe putting bolts in it and stuff. And we'll talk about the different kinds of motion there are. And that's where this gets really powerful is building up a whole robot from individual components like this. And then again, if you do everything parametrically, you can come back and change it, and theoretically nothing should break down the line. But yes, I think that'll be next week. If nobody has anything else, I guess we're good here.